Hi everyone, welcome to another video by Maths with Sarah. So the last two videos that I did were on some grade 9 topics, really tough questions. So one on rationalising the denominator and the other one on quadratic inequalities. So after those two questions that came right from the back of the paper, I've sort of gone from one extreme to the other, and this is tackling a question that is from the front of the paper. So this is a non-calculator question, which may surprise you because it involves circles and finding the area of circles. And it's question 4 on this non-calculator paper, so quite near the beginning, but that doesn't necessarily mean that it's easy. I think this is actually slightly deceptively challenging, especially for a non-calculator paper. So as with all these videos, I encourage you to pause the video now, have a think about how you would tackle this question, at least what method you would use, even if you don't feel comfortable doing the whole question, and then pop back in a few seconds and I'll go through it with you. Okay, so we've got 3 circles. So this is showing the diagram of the logo. We've got 3 circles, and we've been given the dimensions of each. So each circle has the centre at this point O. And Daisy says that exactly a third of the logo is shaded. And they basically are asking, is Daisy correct? And so you've got to show you're working. So essentially it's saying, find the area of the shaded region and see whether or not it's the same as a third. And that's always the way that I would do any of these questions where they say, is this person correct? Or show that this equals, something along those lines. So if we look at this, if we look at how we would actually tackle this question, the way I think we've got to be very logical about each step, because there are so many circles that you've got to work out the area of. It's going to be very easy to get confused, which I think is actually probably the hardest part of this question, assuming that you're comfortable with finding the area of circles. Okay, so the way that I did this was I actually labelled each circle. So we've got the inner circle of it's called circle A, the shaded one is circle B, and then the outside one as circle C. So if we start by finding the area of the centre circle, so circle A, and so the area of A will be pi r squared. Now r is the radius, so this is the distance from the centre of the circle to the edge, the circumference. So in this case, that's going to be pi times 4 squared. So because this is a non-calculator paper, and because you're comparing different distances rather than being asked to give an exact numerical answer, I think we're absolutely fine to leave this in terms of pi. So we can just call this 16 pi and deal with it from there. And that's absolutely fine. But if you do want to, would prefer to say use, for an example, pi equals 3 as an approximation, then that will give you roughly 48. Which you may find easier, and that is absolutely fine. It really doesn't matter. And I've checked on the mark scheme, and as long as you're consistent with the method that you use, it really doesn't matter whether or not you leave things in terms of pi, which I actually think becomes slightly easier at the end, or whether or not you work out a approximate value using pi equals 3. So if we move on to the shaded one we've called B. And we're going to have to find out the area of the total circle and then subtract the area of circle A in the middle to work out just the shaded area. So the outer edge of circle B will be, if we add these together, we're going to get a radius of 7. So that's 7 squared times 5 pi. And this equals 49 pi. But then, because we need to subtract circle A, we're then going to end up with 49 pi subtract 16 pi. And that will give you a total of 33 pi. So this is the shaded region. I'm just going to write underneath just so that I keep complete track of which numbers are what. So this is the shaded region, the area of which is 33 pi, or 33 times 3, which was 99. I'll just put that in brackets. So we've got 99 there, just in case we find that easier. And then finally, we need to find out the area of the total circle in order for us to work out whether or not a third of it is shaded. So if we look at the area, calculate the area of C, as in C being the whole circle in total, we add these three numbers up to get the radius of the total circle. That'd be 4 plus 3 plus 3, which gives you 10. Remember, we've got pi r squared, so r squared would be 10 squared times by pi, and that will give you 100 pi. Or if we're using an approximation of pi equals 3, then that will give you 300. Okay, so for the next part, we need to work out. So Daisy said that the exactly 1/3 of the logo is shaded. So we need to work out whether or not there is a third. So we've got the shaded area as being 33 pi, and the total area as 100 pi. Similarly, if you use these numbers instead, if you had 99 over 300, hopefully you realise you can divide both of those by 3, which will give you 33 over 100. And obviously, in this case here, we can cancel out the pi because we've got that on the top and the bottom. So whichever method you use, you'll end up simplifying it to 33 over 100, or a fraction of 33 hundredths. So the next question is this exactly a third? Is this equal to exactly a third? So the question is, can we simplify this and get the answer of thirds? Well, no, we can't, because we can't actually simplify this anymore at all. So although we know that 33.33333 recurring is over 100 is a third, we haven't got exactly 1/3. Very, very close to being a third, but not exactly 1/3. And so this is absolutely fine if we just, as the final mark, as long as you write no, it's 33 out of 100, it's not 1/3. That will get you the final mark for just explaining that Daisy is not correct, because it is not equal to exactly a third, but it is very close. Okay, so that video had lots of calculating the area of circles, something that I know that some people might find challenging, and that's absolutely fine. Hopefully you're feeling a little bit more comfortable now that you've done it 3 or 4 times to work out this question. And I think a lot of people will be thrown by this question just purely because they can't find an exact answer. You're so used to when you're doing circle questions, just immediately putting this calculation into your calculator and getting an exact answer, so like 48, 49, whatever, you know, with loads and loads of digits on the end, that we forget that we can actually do it without a calculator, either by using an approximation or by just leaving things in terms of pi, and that is absolutely fine. So yeah, I think don't be concerned or don't be worried if you see a circle question popping up on a non-calculator. You absolutely can do it, and it is definitely doable. They won't have given you a question where they're expecting you to find an exact answer with however many decimal places of pi if it's on a non-calculator. If it's on a calculator paper, things are a little bit different. But yeah, don't panic if you see a circle question on a non-calculator paper. So lastly, I just ask you to subscribe to these videos so that you get a first look at any videos that are coming out. And lastly, I just want to say thank you very much for listening.